So, hello to 5th hour and 1st hour, who are far superior to 4th hour, which is by far the dumbest class I have, right? No. Oh, that's me. That's just flat out me. We'll see if anybody from 4th hour actually watches the video. And if you do, if you hear that, congratulations, 4th hour. Then you can call me out on it. The first person to call me out from 4th hour, I'll give you a free candy bar. How's that? So we'll see if you actually watch this video. So we'll try to catch you guys. All right. Okay. Inequalities. If you multiply or divide both sides by a negative, switch the sign. You guys remember that, right? So we have some basic linear inequalities. Example 1 says solve the following inequality, graph the solution set, and write it in interval notation. So what I'm going to do is stare at Charlie Morris. What up, dog? Yeah. What's that best side? How's my friend? Oh, you're exchanging. All right, what's on the iPod today? Little Joe Bonamassa, Stevie Ray Vaughan, Snoop Dogg. All right. Peace. That's gains to talk, if you guys didn't know. Charlie and I have a special connection that way, so. All right, so we got negative 2x minus 7 is less than 9. And this is pretty straightforward. Divide by negative 2, and we have x. Very good. Scott sees it. I need to flip the sign. X is greater than negative 8. But this is just one form of the solution. This is the inequality representation of the solution. I would also like the graph, and I would also like the interval notation. So if I graph this, I plot negative 8, open or close circle, open, and does the arrow go to the right or to the left? It goes to the right. That is the graphical representation of the solution set, and I would also like an interval notation. Any questions? So we could practice 20 of these problems, but you've done that before in Algebra 2 and Algebra 1 even. So let's move on to something a little bit more interesting. Not a lot, but a little. Compound inequalities. Compound simply means more than one. So we have more than one inequality here, and I have ones that are called conjunctions that will end up going together, and disjunctions, ones that will separate from each other. So that's the difference between conjunction and disjunction. Are you guys old enough or young enough to know the conjunction, junction, what's your... I never heard that before, and but every time I teach math, when I bring that up, people remember that. So where's that from? It's from English class? So you guys have watched it in English class. Bryn doesn't know what we're talking about. Oh, you don't know what we're talking about. Carissa. Okay, so it's a curriculum piece. All right. Okay. Cool. Schoolhouse Rock. Yes, that's a phrase that sounds familiar to me that people know about. Okay, interesting. All right. Well, if you see a conjunction, you need to separate into two inequalities. Can you tell me the two inequalities I get from this first example right here? Very good. So that one, and then 3x minus 7. A lot of people just attach the 3x to the negative 9 and the negative 7 to the 11. You can't do that. You combine these two, and then you combine these two. So you have to do both sets. So now I solve. I add the 7. I get negative 2 is less than 3x. Divide by 3. Negative 2/3 is less than x. That's my one solution. My one boundary, maybe I should say. 3x less than or equal to 18. So x is less than or equal to 6. So I need two ways to represent, well, three ways. I have the inequality portion here. I would also like to have the graphical representation. So, Cini, we were so worried about you. Carissa said she was glad you were gone. Don't want to make for an awkward moment. Open or close circle on the negative 2/3. Open or close on 6. Closed. And if we graph x greater than negative 2/3, it will go to the right. And x less than or equal to 6, it will go to the left. And you can see that they do in fact meet in the middle. So that is our graphical representation of the problem. The question. That'll be fine. Same inequality. And finally, the interval notation would be negative 2/3, comma 6, and you'll put a bracket on the 6, and you'll put a parenthesis on the negative 2/3. So there we have our final solution, as it says, interval notation. Oh, it's all Van graph, so I've solved it, graphed, and I put it in interval notation. So I did all of them. Okay? Why don't you try the next one on your own real quick, okay? Take a minute, do the next one on your own. Question. Yeah, and it looks like the type of font I was using didn't really show up as well as it should have. It's just a negative 4x. It's not a negative as some people thought last hour. Give you a few seconds to start here, and then I'll slowly work behind you. Does everybody have that? Well, here's my question for you. With that type of problem, there's a few mistakes that people will generally make. It's not really that difficult of a problem, but there's a few just small little pieces that people mix up. So can you identify something that people might do incorrectly on that one? Yeah. Oh, good question. It should be or, because you can't live both in this region and this region, right? However, if you said and, I would understand exactly what you're doing. So, well, no. Okay, I'll accept either, okay? This has to do, remember at the beginning of the year we talked about unions and intersections? Okay, so technically the way that we would express this is -8, -5. So math doesn't always like the words and or, so we would use a union. So combined with that. Okay. So everywhere here, unioned with everywhere here. I was going to show that notation on Monday, but you asked the question now. So good. Bryn, you had a question or a comment? A mistake that people would make. Yeah, how would they maybe draw the graph incorrectly? Very good, you got it. So here's the most common mistake. People would put the -2 over on the left and the -5 over on the right. Why would they do that? Because that's how it's written right there. And furthermore, they're used to putting the number with the larger absolute value to the right and the smaller absolute value to the left because they're so used to dealing with positive numbers. So remember that you need to, really put them in the correct order down here. I just don't want you to get have mistakes. If you did put the -2, -5, if you switch them, the arrows would come together and join, and you would realize, hey, wait a minute, this is supposed to be a disjunction. Okay, Last example, nonlinear inequalities. We're going to look at quadratics today, and we're going to solve it by two methods. The first method is what you're going to do today, and it's the easiest method. I'm going to show you the second method so you can solve more difficult ones. Because eventually, we want to solve stuff like this. We want to solve x over 3 plus 4 plus x over x squared plus x is less than 2x. I mean, we want to solve that kind of inequality. That's much more interesting. And it's really not that bad. But you can't use the first method to solve that. So, again, we have two methods. Number one is graph. Number two is called a number line test. And that's what we're going to have to spend a while talking about, is a number line test. So I'm going to expose you to that idea now so it's fresh in your mind come Monday. So let's start off this problem by subtracting 15. I know that's what everybody wanted to do because you all understand the zero product property. And now we need to pause and we need to think about exactly what the problem is asking. It says x squared plus 2x minus 15 is greater than 0. On the number line, what does it mean to be greater than 0? Not negative, or if it's greater than 0, we know it's not even equal to 0, so therefore it has to be positive. So you are wondering, where is it positive? Okay? Now, if we were to view the x and y axis and make a graph of this parabola, what does it mean for a graph to be greater than 0? Above the x-axis. So we're going to do the easy part today. We're going to sketch the x and y axis here. And I'm going to find the solutions to this as though it was equal to 0. So this is going to factor to x plus 5 and to x minus 3 is greater than 0. So what are my solutions to that? Negative 5 and positive 3. So I'm going to plot negative 5 and positive 3. And just for good measure to keep things in order, should I put open or closed circles? Open. I want you guys to know that what I'm doing right now, this is not the solution. This is the scratch work to get the solution. This is just a method by which we will go about it. So this is just scratch work to help me solve it, okay? Now, does this parabola go up or does it go down? Why does it go up? Because the x squared is positive. Not because it's set greater than 0, but because the x squared is positive. So therefore, when I draw my graph, I want to draw it going up. Now that I have a basic sketch of the graph, I can now understand this. For this section of x values right there, is the graph positive or is it negative? It is positive because it's above the x-axis. For this section right here in red, is the graph positive or negative? And finally, the last section we know is positive. So to answer the question, and the question just says answer in interval notation, we know by the graph that we drew, we can now submit the answer, which is the graph is positive from negative infinity. That was really bad. To negative 5. And we would say we will union that with 3 to infinity. So again, union, a symbol that I introduced today that I wouldn't normally do till later. So the other group didn't see that. But Taylor had such an excellent question. Any questions there? Questions? I don't care. I want you to understand what the back of the book has, and I was going to bring that up on Monday. So. Okay, and then number line test, that's slightly different. We draw the number line, and we want to look for values that are positive on the number line. Okay? So here's what I'm going to do. I plot my numbers -5 and 3. Now, I know, again, you might be thinking to yourself, why would we do it this way when we can do it the graphical method? Because we're going to try harder problems. So I just want you to see this basic method right now. I'm going to test points. Give me a number to the left of -5 that I could test. -7. You don't need to know the exact value, you just need to know if it's negative or positive. If I plug -7 into this part, is it negative or positive? Negative. -7 minus 3? Negative. And a negative times a negative is positive. So any number that you plug in to this side of -5 will give you a positive result because it will result in a negative times a negative. What is the number between -5 and 3 that you should plug in? 0. 0. If you get a chance to plug in 0, choose 0. 0 plus 5, positive or negative? Positive. 0 minus 3, negative. Positive times a negative is negative. And the last one, plug in a number to the right of 3. If we plug in 4, 4 plus 5 is positive, and 4 minus 3 is positive. I get a positive times a positive, which is positive. Notice how this solution matches what we did graphically. So there are two methods by which you could solve these type of expressions. The graphical way is probably easier for most people. The number line test is something we'll have to utilize eventually down the road. So again, to answer the question, you want to know where it's greater than 0 or positive. What's greater than 0 there, and it's greater than 0 there. So you can write your final answer again as -infinity to -5, union with 3 to infinity. Got it? You like that? That's all I've got for you. So, what I want you to do right now is you have the rest of the hour, which is 24 minutes in time, and I have the odds, 9 through 29 odd. Somebody didn't know this last hour, all the odds are in the back of your book for solutions. So I'll tell you what I told them. Don't bite the hand that feeds you. I'm giving you the odds so that you may check. As Alexa, thank you. No, I'm scared. As 9 through 29 odds, you can check those answers in the back of your book. So as you're working this weekend, there, check your answers. Now, if you simply write down the answers, I don't like that because then when I check your homework, I take points off. And I realize that you're a slacker. And then every time I go through your homework in the future, I look at your homework with a magnifying glass. In fact, one person a few years ago didn't think I actually looked at your homework, and he wrote on one of the pages, of the 10 pages he handed in, he wrote on one, he said, I didn't do any of these problems because you don't really look at this, ha ha ha. And he's not thinking I wouldn't see it. And, oh, I saw it. Because I do look at all of your homework. I don't answer every question, but I do look at them. And so, trust me. In the future, I found not only every problem he didn't do, but I found every problem he didn't do correctly, too. So, you had to put up with me for the rest of the year. So, do the problems just like you're supposed to. Do a good job with it. You'll be great. I'll hand back your study guide, and I'll hand back your homework that I graded. I want you guys to know, people ask, what should we do with this? Erin Everhart. Anybody know Erin? Erin, one of the smartest people I've ever taught. Erin kept her study guides and her notes. Tossed her homework, but kept the study guide and the notes. Took it with her to college. She said she used it for some of her college courses, that it helped her. Your study guide is excellent for you to keep because it will be a great reference for studying for the final exam. Because your final exam, the study guide for that is 20 pages in length. And you don't have to do the whole thing. But the way I get the study guide is I put all of your study guides together, basically. That's about what I do. So if you have your study guide already completed, you can go back and look to see what did you understand and what didn't you. So don't do the whole study guide. Unless you really want to. But keep your notes so that you have something to go off. Have a good weekend. 4th hour. In case anybody's watching, which I doubt you are. Sydney, do you have a message for 4th hour? Steenie wants to say that 4th hour is inferior to 5th hour. So track her down on Monday.